Here's a quick demonstration of Trefoila, which is an optical design software at only $49 a month so that educators, students, individuals, startups can afford it. So when you open the app, you'll have to activate your license, but since it's in beta right now, I gave everybody a license for free. So just go to the website, copy that, and put it in here, and activate your software. So we'll start off looking at a Cook triplet, and when it opens up, you have your 2D view, you have a surface table and a modulation transfer function by default. On the setup tab, which is the first tab, you can choose between different examples. So we have a double Gauss, an Earthly eyepiece, the Hubble telescope, an objective, but for now we'll just stick to the Cook triplet. We have our table here that kind of shows us the tree of the optical system, and we can edit things like the wavelengths. So when you click a button in the ribbon, you'll have little glowing things, and here you can decide where you want your new window, and they'll share space. So for example, I could do that, and then I could select my wavelengths that way. But you can change the wavelengths, the fields, the aperture, object difference, distance, units, and you could also open files that are .trf. That's the format of the software. In the construction tab, we have buttons that are helpful to actually build the system. So here we can move surfaces up or down. We can change the surface type. So if I want this to be a conic surface instead of a spherical surface, we just hit that. And then you can double tap this and change your aspheric coefficients or the conic K. We can also change the kind of glass. So for example, if I want this instead of F2 to be something like NBK7, I can just put in BK7 and click that and apply it. And obviously that has its impacts on actual convergence of the system, so we'll just undo that. But we could also work with coatings, and if you're building more complex systems and you want things to either solve for each other or be related to each other, like measurements, we can use solves, pickups. And on the analysis tab, we can analyze the system that we've built. So we have a spot diagram, we have Rayfan, point spread function, and lots of other tabs. So once you actually have your system, you can actually analyze it and see how its progress is and how well it performs. In the optimization tab, if we don't have a system that's already optimized like this Cook triplet, so for example, let's say I don't know what the radius of the first surface should be to give us a nice convergence, you can optimize it. So we can open our optimization studio, check the variables that you want to be open for optimization. So we'll change S1 radius, which is the first radius right here. So we'll make the range, let's say 0 to 100, and we'll use something like Nelder-Mead. And for the merit function, we'll do the root mean square spot size of all three fields, and we'll just run that. And then hit accept, and you can see that all of them are converging nicely now as it went back to that original value. And the V just means that it's a variable now when you optimize it. Other tabs here are just kind of parts of the optimization studio if you want to really focus on that. So for example, you could just open the variables window. In the tolerancing tab, if you're planning on actually building a system in real life, it's important to know which surfaces you need to worry about tolerances most for. So we can open the tolerance studio, and by default, all of the possible deviations from the ideal system are listed here, or all the ones that the software handles. But we can change that. So if we just want to look at radii, we can hit this and then auto-populate and run a sensitivity, and we can see that the surface 2 radius, which would be this one, is the one that's most sensitive to tolerances. You could also run a Monte Carlo and see what root mean square spot size 90% of the systems given these variations from ideal will be under. So for this one, it looks like it's about 12.6 micrometers. And lastly, we have the View tab, where you can export PNGs of tables or graphs, or for more numerical things like this modulation transfer function, you can export CSV of it. And last but not least, because this is a beta software, there are bugs in the software. So if you're using it and you find a bug, you can hit this report bug button, and then you could explain your bug. So say Command Z isn't working, and it'll save the state of your project and send it over to me, and I'll take a look at it and get it fixed. Thanks for watching.